In this video, we're going to take a look at the 6th race condition lab on Portswigger's Web Security Academy. The lab is called Exploiting Time-Sensitive Vulnerabilities. So let's go through this background information before we jump into the practical lab. It says that sometimes you may not find race conditions, but the technique for delivering requests with precise timing can still reveal the presence of other vulnerabilities. One such example is when high-resolution timestamps are used instead of cryptographically secure random strings to generate security tokens. Consider a password reset token that's only randomized using a timestamp. In this case, it might be possible to trigger 2 password resets for 2 different users, which both use the same token. All you need to do is time the request so that they generate the same timestamp. And that's it, let's take a look at the lab. So the description says, this lab contains a password reset mechanism. Although it doesn't contain a race condition, you can exploit the mechanism's broken cryptography by sending carefully timed requests. To solve the lab, we should identify the vulnerability in the way the website generates password reset tokens, and then we should obtain a valid password reset token for Carlos, log in, and then delete the user Carlos. Okay, so let's open up the lab. We can log in with the usual credentials, Wiener and Pizza. So let's start by opening up the email client. We'll need to go and check the emails as they come in there, and let's go and try and reset our password straight away. So we go to forgotten password. We can enter in a username or an email. So I'm going to do Wiener and then click submit, and it says that it has been sent. So we can go back to our email server and we'll see that we do have this token. It's quite a long token, doesn't look like something that we'd easily be able to guess or predict. But let's take that copy of the forgotten password request, send it to the repeater, and we'll go and send this a few times. In fact, let's just go ahead straight away and we'll do our Control and R to create multiple tabs, and then I'm going to add these to a group, add all of the tabs, change the color and the name, and then we can either send these in a sequence or send them in parallel. I'm going to try and send them in parallel. So we'll send all these off. Let's just see, do we get different responses? First of all, this one came back in 399 milliseconds. The second one was 1,600, and then 1,704, 1,313. All right, there's a big variation in the timestamps of these. So if this was based on the millisecond, none of these are coming back in the same range. If we go back to our email server and have a flick through these, we basically want to see, is there any kind of pattern to the tokens? So does it increment each time? Does it decrement each time? The problem is it looks like some kind of hash. So maybe the timestamp is hashed, but that could be combined with the username. It could be combined with an email, with a random salt, with anything. We really don't know how it's generated. Now, I kind of got stuck here. I basically went back and I just used 2 requests and set one to Carlos and one to Wiener and kept trying to send them through, and then I would try to use this token with the username Carlos, just hope there was some kind of collision. But because there is such a variation in the timestamps, that's not going to work for us, and apparently the reason for that is actually the session, which wasn't something I knew to try. So if we get a new session token, we can get a new one. Let me send this to the repeater again. And I'll change this to a get request, and we can just get rid of this stuff. And basically just want to remove the session token. In fact, I removed too much. I'll remove the cookie altogether. And then let's just send this current tab. And it should come back then, give us a new session ID. I should have kept that cookie in. Oh well, let's change this to... In fact, we don't need to add this here. We'll do it over on our second request. I'm going to change the session ID. And then we also need to change the CSRF token. So I'm going to go and get that from the response. And we will add this here. And we'll just keep it as Wiener for now. Let's just try and send both of these off. So we're doing the same thing. We're doing a password reset. We're going to send them as a group in the single packet attack. And click send. The second one took 358 milliseconds. And the first one took 358 milliseconds. So exactly the same time. And that's obviously because we using different sessions. So it's tied to the session. And if we go back then to our email and have a look at the 2 emails we got, they both have the exact same timestamp and they both have the exact same token. So if we just go back now and change the second request username to Carlos, send these at the same time, we'll go back to our email server. We've got a new email, and then presumably Carlos also has the exact same email with the same token. So if we take a copy of ours and we go here and then we'll just change the username to Carlos and it says invalid token. Oh wow, that didn't work. Okay. Let me go and check the response. Did it say anything? No. Okay. What was the response time? 87 and 347. Okay, so there's a very different response time in this case. Let's try it again. In parallel, the first one is 353, second one is 83. Also the same. I wonder, do I need to change the session ID again? I don't believe so, but let me give it another go. I'm going to send this. I'm going to change it to a GET request and then just send it on its own. Oh, I forgot to take out the session ID, and I also deleted the host again. So we'll get a new session ID. Let's go back and set this for Carlos. And let's also get the CSRF token. There we go. We'll get rid of that other request, and then we're going to send these in parallel. That one took 62 milliseconds. The first one took 369. Okay. Let's just try this again, out of interest. I'm not sure what I'm doing wrong here. I already solved the lab and it worked. Oh, okay, that one did work. All right, maybe I just needed to do it a couple of times. It probably wasn't related to the session token, because the last time I didn't have to do that of changing the session token. But anyway, it worked. Let's change our password to cat, and then we'll go and log in, Carlos, cat, and delete the user Carlos, and we've solved the lab. Since that was the final race conditions lab, let's also have a look at how we can prevent these kind of vulnerabilities. When a single request can transition an application through invisible substates, understanding and predicting its behavior is extremely difficult. This makes defense impractical. To secure an application properly, Portswigger recommends eliminating substates from all sensitive endpoints by applying the following strategies. Avoid mixing data from different storage places. Ensure sensitive endpoints make state changes atomic by using the data store's concurrency features. For example, use a single database transaction to check the payment matches the cart value and confirm the order. As a defense in depth measure, take advantage of data store integrity and consistency features like column uniqueness constraints. Don't attempt to use one data storage layer to secure another. For example, sessions aren't suitable for preventing limit overrun attacks on databases. Ensure your session handling framework keeps sessions internally consistent. Updating session variables individually instead of in a batch might be tempting, but it's extremely dangerous. This goes for ORMs too. By hiding away concepts like transactions, they're taking on full responsibility for them. In some architectures, it may be appropriate to avoid server-side state entirely. Instead, you could use encryption to push the state client side, for example using JWTs. Note that this has its own risks, as we've covered in the JWT attacks section. And that's it, we have completed all 6 of the race conditions labs. However, Portswigger did add a 7th lab, which is in another category. So next week, we're going to take a look at that one, and hopefully they'll add some more race conditions labs in future, because I've really enjoyed covering these. Finally, if you want to find some race condition vulnerabilities and get paid for it, you can check out the Intigriti platform. And I hope you've enjoyed this video. If you have any questions or comments, leave them down below. Thanks.